Number 5. We will start with subtracting 1 to the other side. That's negative 2x squared is equal to negative 7. Next, we'll divide both sides by negative 2. That gives us x squared is equal to positive 7/2. Then we undo the square, do the opposite of the square, which is the square root. We personally wrote the square root sign, so that's a plus minus. Can't take the square root of 7, so we leave that alone. And we can't take the square root of 2. Uh-oh. Well, is that okay to do? And the answer to that is no. We don't have a problem with the radical 7, but the radical 2 cannot stay there. So before we finish this, we have to talk about squares in the denominator. We can't have a radical in the denominator because it's like having a decimal in the denominator. A non-perfect square is a decimal that goes on forever and ever and ever. So if I have 3/4, well, I know how to get three pieces out of 4. But if I had 3 radical 7s, I don't know how to take 3 pieces out of radical 7 because radical 7 is some long decimal. So we need to do something called rationalizing the denominator. We want that denominator to be a number that we can actually have that many pieces or cut a pie into that many parts. Rationalizing the denominator basically means whatever the radical is in the denominator, we're going to multiply by that number. So 2 times radical 3 is 2 radical 3. Remember, we can't actually multiply them because they're not like terms. So they're just going to have to sit next to each other. On the bottom, radical 3 times radical 3 is radical 9. Oh, but wait a minute. I know how to take the square root of 9, and the square root of 9 is 3. So I cannot simplify the radical 3 over 3. One's a radical, one is not. So they are not like terms. So 2 radical 3 over 3 is my answer to that. And that's okay because I know how to have 3 apples or 3 bananas or 3 Snickers bars or cut a pie into 3 pieces. I know how to do that. And so that's okay. Example B. I'm okay with the 2, but I'm not okay with the radical 5 because, again, I don't know how to make radical 5 pieces. So we're going to multiply the top and the bottom by radical 5. On the top, 3 times radical 5 is 3 radical 5. On the bottom, we keep the 2. Radical 5 times radical 5 is radical 25. Oh, well, I know the square root of 25 is 5. And remember, this is multiplication because there was no plus, minus, or division in between our 2 and our radical right here. So 2 times 5 is 10. I can't reduce the radical 5 and the 10. They're not friends. They're not like terms. So this is the answer. And again, it's not pretty, but I know how to have 10 books or 10 scoops of ice cream or 10 pieces of pie. Okay, now to our last one. We talked about in section 3.0b, where as long as they're radicals, they're friends. And so can we reduce 2 and 6? And the answer to that is yes, we can. 2 over 6 simplifies to 1 over 3. And again, I can only do that because the 2 and the 6 are both radicals. So on the top, what is the square root of 1? Well, it's 1, and 5 times 1 is 5. So from there, again, I don't like the radical 3 on the bottom. So I'm going to multiply by radical 3 over radical 3. 5 and radical 3 on the top are not friends. They're not like terms, so they just sit next to each other. This 3 out in front stays there, times radical 3 times radical 3 is 9, radical 9, and the square root of 9 is 3. So we have 5 radical 3 over 9. And remember, the radical 3 and 9 are not like terms, they're not friends, so I can't do anything with those. And 5 radical 3 over 9 is the best that one will get. So if we go back to the end of our last example of x is equal to plus or minus radical 7 over radical 2, now we know how to finish that problem, because I don't care about the radical 7 on the top, it's the radical 2 on the bottom. So I'm going to multiply the top and the bottom by radical 2. On the top, 7 and 2 are both underneath the radical, so I'm allowed to multiply those together to get radical 14. And on the bottom, radical 2 times radical 2 is radical 4, and the square root of 4 is 2. Remember, the 2 on the bottom and the 14 on top are not like terms, they're not friends, so we can't do anything with them. And so x is equal to plus or minus the square root of 14 over 2 is going to be the final answer for that. This is where we're going to stop today. Make sure if you have a graphing calculator, you bring that with you tomorrow so we can talk about the first page of these notes. Have a great night.